Hello, everyone. My name is Galen Stetsuk. I'm the president of the Virtual Reality Club, and this is Mike Sorokin. He's the vice president. We just established the club just last semester. We're working with the Terrapin Hackers today to give you guys a Hacktorial on some VR development basics. So we're interested in virtual reality. We actually started our own company just a few months ago, Mplex. And we're working for our first product, which is a virtual reality tank combat multiplayer video game. But of course, VR isn't going to be limited to video games. You can have all sorts of different applications to work on. These practices are going to apply to just about any one of those. Now, what you should get out of this Hacktorial, we're going to cover some of the virtual reality headsets that will be soon to be hitting the market. Some best practices for virtual reality development, whether you're making a video game or a surgeon simulator or anything to do with virtual reality. And some of these best practices can transfer to AR as well, but we're mostly going to be covering VR. And then if we get through the slides, we're going to actually be doing a quick tutorial both on Unreal Engine and in Unity for enabling VR development. We're using those two game engines because you can acquire them, or most of them, for free. So what makes up virtual reality? So, and the way we see it today, virtual reality is composed almost entirely of head-mounted displays. There are some companies that are trying to approach virtual reality through the different senses, like smell and even taste in some cases, touch, things like that. But most of it is revolving around the headsets. Now, virtual reality doesn't just have a screen that's attached to your face, strapped onto your head. Most of them have a camera tracker that actually tracks the position as well, because if you lean over, it's going to track the rotation, but the position still needs to be tracked as well, and that's how the camera is involved, this little guy right here. And an input device, so it could be a mouse and keyboard, or with Oculus, it's going to be a Xbox One controller. And then there's also going to be motion controllers as well, similar to like the Wii U or just the Wii. And they're going to be called the half-moon controllers in Oculus' case. There are a few other companies that are making their own motion controllers as well. So the Oculus Rift. Oculus is the founder and CEO of Oculus, Brandon Uribe, just made a big donation to the University of Maryland. In the amount of 31 million, along with 5 million additional, and a bunch of equipment for us to use for development. So the Rift is mostly composed of the Samsung Galaxy S2 for the Rift DK2. This actually uses a Galaxy S2 screen for the display, an accelerometer, gyroscope, and magnetometer inside of the headset to track rotation. And then the IR tracker for the camera is meant to track the position. So that's the Oculus. There are also going to be other headsets as well. The HTC Vive is a really interesting one. In my opinion, it's being developed in collaboration with Valve. And this one uses sort of external laser tracking system to track head movements rather than the accelerometer and magnetometer that Oculus uses. There's also the PlayStation VR, which is going to be Sony's foray into virtual reality. That is going to be used entirely with the PlayStation 4. And the one really interesting one is called the OS VR, which, if you are ever interested in, you can actually go to osvr.org and see some of the development code for the headset itself and actually contribute to it. So if you are interested in actual software development of the headset itself, you can actually go there and make contributions as well. I thought that was pretty interesting. So there are some challenges with virtual reality, right? It's not just attaching a screen onto your face. There's a lot of technology that goes into it in order to make it work. Virtual reality has been attempted several times in history and has always failed due to many of the challenges not being met. So Oculus and a few of the other companies that are producing VR headsets are trying to meet some of these challenges, which include the latency, the resolution, and something called the divergence accommodation conflict. Mike, do you want to
Sure. So what the divergence accommodation conflict is, basically, if you imagine you're watching a sports game on a television set, and you're watching all these players moving by, and your eyes are focusing on a specific player, but things are going on in the background that make you distract your eyes. So there's a miscommunication between your eyes and your brain. And your eyes are trying to center on a specific object while your brain notices surrounding objects, and there could be potential consequences in this, such as double vision, where you are not centered on the object and it appears like it is kind of distorted, and you get sort of a blurry image. And this blurry image in a virtual reality headset is something that needs to be fixed and is a challenge, because how do you make it so that you can have your viewers focus on a specific thing? You can have your users not be distracted with all the stuff that goes on VR and get all this blurriness that goes on. And this is a challenge that people are facing, just like the fish in SpongeBob with his eyes burning. You don't want that to happen when you're in a VR environment. You don't want your eyes to be strained. So that's basically what divergence accommodation is.
This is not meant to scare anyone. They're working on it. And your eyes won't burn out of your skull. It's just something that will give a little bit of fatigue after a long period of time with virtual reality, because the screen is never changing any distance away from your face. It's always going to be a few inches from your face. That is going to be causing that sort of thing. We'll actually leave questions to the end. We'll take an intermission in between where we'll answer some questions there, and then we'll jump into the game engine. We'll answer more questions at the end there as well. So latency and resolution are some other things I'm going to talk about. So the resolution. So the human eye, at least some experts say the human eye's resolution, at least the maximum resolution that one eye can take before it's not going to notice any finer detail, is about 8K resolution per eye. So that's extremely high. Ultra HD televisions are only 4K, so you'd have to, pack 2 of them for each individual eye. Now, many of you probably know we're not quite there yet. There are some displays that can get close to that, but it leads into much more expensive hardware that's not really consumer friendly, and I'm going to talk about that in a little bit. The DK2, which is what we have, is 960 by 1080 resolution, which is very high. It's nowhere near 8K though. That's per eye. So the screen is actually split into 2 different screens that render the same image, or a very similar image. It's just from the distance between one eye and the other. The CV1 is actually going to have a much higher resolution, a little bit higher, about 1080 by 1200. Same as the HTC Vive, and the PlayStation VR is going to be about the resolution of the DK2. So refresh rate is another challenge that VR is faced with. Some games can get away with 60 frames per second. Some can get away with even 30 frames per second, but they're being rendered on a monitor. When you incorporate motion as well as the refresh rate of a screen in a head-mounted display, the refresh rates start to become much more noticeable when you move your head, because your body is very good at detecting where an object is and where it should be, where you're viewing it. So some experts say that about 120 frames per second is about optimal before you're going to notice any sort of latency in the refresh rate, and some experts go all the way up to 200 frames per second. So those are the frame rates of some of the big consumer versions. PlayStation VR actually can do 120. It's really 60 frames per second. They just fill in each frame's running at 60 frames per second with the pixels that are in between the 2. So it's not truly 120. It is technically, but it's not true. 120 is more like 60. Motion tracking and latency. So this is something that's very hard to gather data on, because we can't really tell, other than the actual input device itself, where somebody's head is supposed to be positioned, or where it is positioned exactly at any one time when the person is expecting to be viewing at that certain angle. So Oculus is saying that they can get their latency down to 20 meters or 20 milliseconds. That's like the delay between you turning your head 1 degree or changing from one position to the other, and having the Oculus send the information to the PC and back to the screen to render it to match the orientation of your head. It's never going to be right on time. Now, Oculus does use a lot of technology that predicts where your head is going to be pointing based on vectors and movement, but for the most part, it's about 20 milliseconds delay, which is not really noticeable to most people, although it is noticeable to you. I personally haven't noticed any lag when it's running at optimal speed like that, but some people might. Some people do notice that, and that's a challenge to face as well. But another one that is not solved at all is depth, and this plays a little bit into the divergence accommodation conflict. Depth is something that's very difficult to recreate on a 2D screen that's only a couple inches from your eye. There's some tricks that some people use, like there's actually a headset called the Fove that's still really an early stage of development that actually just blurs the portions that you're not looking at in virtual reality, so it tracks your eye and it blurs everything else around it, so it sort of looks like you're focusing in on that. You're not actually truly focusing though, because the screen is only a couple inches from your face. Now, Magic Leap, they claim that they have some technology that actually allows you to actually like squint and focus on certain things in virtual environment, but that's also very early stage, and for the most part, this problem hasn't been solved. So all of these factors go into the cost of the headset, right? So we actually have the capability of making a headset that is way better than the consumer version, but it's going to be extremely expensive. There's no really way to avoid it right now. The technology isn't quite there yet where we can have an 8K resolution per eye and be able to sell it for $200 or $300. It's going to be like $1 million device. So the cost is definitely a big factor for virtual reality succeeding in the mass market. And it's one of the biggest issues right now, since Oculus is the only company that actually has released a consumer version of the Oculus, of a virtual reality headset. It was more than what people were expecting, and when the other headsets come to market, I think it's going to be more than what people are expecting as well, just because the tech is so new, and it's really expensive to incorporate all these technologies that I've addressed in order to address those challenges in virtual reality. All right, so there are these two game engines, Unity and Unreal Engine, and I love these two game engines. They're free, at least for the most part. These just describe some of the royalties that you'll incur if you create a product and sell it. So if you sell over $100,000 worth of products that have been made with Unity, you don't get charged anything until you make that $100,000, and then they'll charge you full price for Unity Pro, which is $1,500. And you can always buy Unity Pro before you get to that stage. But Unity Pro has a little bit of extra elements in the game engine that you can use for development that the free version doesn't have. Unreal Engine is entirely free, although they charge 5% royalty on anything that sells over $3,000 worth.
And something to point out with both game engines is that the community. So with Unity, there is a vast amount of resources that you can get in order to address your problem. So Unity, if you're unfamiliar with the game engine, it uses a lot of C# scripting. And there is a forum on the, I think, official Unity forums where people just address a lot of these questions and also address particle systems and just anything that goes on in the Unity game engine. And the good thing about Unity as well is that it's asset store. You can download a bunch of assets that other people make, and these assets could be anything from putting in like a A-star path finding algorithm in order to implement in your game. and it's just a lot of information available. Some are free, and some you have to pay for. But it's a lot of resources that are available in the asset store, and also you can get help from other users who use Unity. But Unreal is a lot of, so you'll have to dig deeper into obtaining the information if you have a lot of problems, because not a lot of people have been doing stuff with the newest version of Unreal, since it is very new and it's a lot to learn on your own. And also there is an asset store, but it requires, it's not as many resources as there are in Unity. So if you want to go in with Unreal, there is a bigger challenge you may face, in that you may not address your problems right away, but it is, we'll discuss in the next couple of slides how Unity differs from Unreal, but you would have to learn a lot on your own.
Yeah, and assets are mostly composed of like tools to create certain things in your game, like making certain environments, or like you said, implementing certain scripts like the pathfinding algorithm. So the pros, and also a big thing to note is that Unity and Unreal are also being addressed in this presentation today, because they both render virtual reality headsets, and it's actually very easy to enable VR, as we're going to show you in a little while. So Unity 3D is a drag and drop interface that they code with C#, which is very similar to Java. So if you've been through a 131, and a little bit of 132 knowledge has been used with our project so far, you'll feel right at home with C# for creating scripts quickly and working through that. It's a little bit less powerful in terms of the graphics engine. It is free, but it's lacking features of Unity Pro, and well, another comment is that when you're updating versions, you're going to get potential issues, but that's the same thing with Unreal Engine as well. And Unreal Engine, the graphic fidelity is a little bit higher. You can actually work on a virtual reality application without actually knowing any code. You can use the nodes-based code editor to make game logic or work with materials. But some cons is that there's a little bit more of a learning curve with Unreal Engine, and the physics engine isn't as powerful as it is in Unity. So these are some graphical comparisons. You can see both brass sort of spheres actually look very nice in both game engines. They look a little bit different. So some people will argue, well, Unity's graphics engine looks just about as good as Unreal's in this case. And I wouldn't necessarily refute that, but it's just my personal opinion that Unreal Engine just looks a little nicer to me. But you can leave that up to whatever application that you're going to be working on your own. You can decide that for yourself. All right, so we can take a few questions now. We'll probably start back up with some best practices and jump into the game engine at 7:23 or 7:33. So I'll open it to questions now. Yes.
That accommodation error, is that what's called?
Convergence accommodation conflict?
Yeah. That's that issue also in like 3D movies?
Yeah, that is, as I was talking about the example where you see on television with the sports, that's because of the screens on the Oculus and on a TV set, you're never going to get that communication between your brain and the eyes that you want to really center in on an object and make it not appear blurry. And yes, that is a problem with a lot of movies today. And it's been known. It's been a really recognized problem, but the thing is how to get this for VR. That's a solution that is yet to be found.
And many people can't, like, they won't immediately notice there's an issue right at hand. They might feel like there's something a little bit wrong, but they won't actually really be able to tell what it is unless you're, somebody who works on it all the time like we do. Um, it's what it mainly causes is fatigue after a while. So if you have a virtual reality headset on for a while, you might feel like you're tired of it after a long period of time. And part of that is due to that phenomenon.
Are there any more questions? Okay.
All right, yeah, we're gonna take a little break. We'll come back at 7:35 or 7:33. Oh, yeah. Oh. Oh yeah, we could switch it up. Oh yeah, it's really. It's okay. You might be probably dead.
Yeah, we're about to discuss let's switch back.
Yeah. Yeah, yeah. So I'll do it. No, don't mess with me. Or no, I don't want to.
Okay. Yeah, just,
I think the project is definitely the reason why the project is pretty screwed. It's not just yeah. All right, go ahead.
Okay, so right now, right before the intermission, we discussed a few things about Unity and Unreal and the benefits of both of them. But right now, we will go ahead and talk about how to enable VR in both Unity and Unreal in order to set up your own projects if you wish to do so in the future. So it's really easy. All you have to do is in the Unity project, once you create it, you just go and I'll show you how to do this in a second, but under player preferences, you literally click the button. It couldn't be that much easier. So yeah, we'll show you how to do that right now. So switching over to Unity, and I have a project already set up, and it should appear in here. This is just going to be a basic scene. Okay, so you can see it there. It's a basic scene that right now has a sphere, and it's called Crashing Sphere. You'll see why that is in a bit. And so as I was describing, if you want to set up VR on your project, you go to Edit, then Project Settings, and then you go to Player. And then right here, you should see under Other Settings, you should see a Virtual Reality Supported option. And if you have your Oculus Rift DK2 plugged in, then this should work fine. And if you don't have an Oculus Rift with you, you can just go to the VR club during our office hours, and you'll be able to try some stuff out with VR if you wanted to. But basically, right now, if I were just to play this, then you can see the bottom screen that's reacting to my movement of this Oculus head-mounted display. And right now I'm getting a good solid 75 frames per second, which, as we described, was the optimal frames per second we want on this Oculus Rift. So what happens when we have objects that are really to make the Rift perform poorly, such as they lower the frame rates, as we see here. So that's what this crashing sphere, which is what it's called. So we play it. If I head into the scene, play it, you can see that's a measly 34 frames per second. And the reason why is because if I zoom in, if you see the top screen where it says scene, if I zoom into that object, this has a lot of vertices. This has 1 million vertices on the entire sphere. And that is why the frame rate is so bad. But if I look away, it goes to 75. If I look at it, it's dropping so poorly. So I created this sphere in Blender, which is a 3D modeling program where you can create 3D objects. And as you can see here, about 1 million vertices. And that's something you really don't want to have when you're creating something virtual reality, because unlike most games, which require like at most 60 frames per second, around 30 frames per second, you're not going to get stuff like a really good looking sphere, even if it looks really crisp up close. So you want to limit the amount of vertices that are on the sphere. And so that's what this, if I deactivate this and enable what I call the good sphere, which you can create in Unity by just going to create 3D object, and they have a default sphere. If you click on this, it doesn't tell you how many vertices there are, but you can tell that it's a lot less. And if I were to play this now, and look at the sphere, I'm getting a nice 75 frames per second. Then if I activate this, oh god, it's starting to stutter. And you can really see it in the headset. So if you want to try it out, not this, but if you want to try out some VR stuff, then you go to the VR Club office hours, which if you're part of the VR Club group, then you have the information. So this is Unity. This is how to set up a virtual reality environment in Unity. But going over to Unreal now, that's not Unreal. This. So going over to Unreal, it is also very easy to set up something in for a VR environment. There is literally a VR preview dropdown from this play button, and you can see your VR environment. And what we're going to show you right now is actually something from our game that we created, our tank game, where we made Galen described it before, we made a virtual reality tank game that is multiplayer. And so right here, if I just go to the drop down VR preview, there's a preview of Unreal in virtual reality. And this is the tank, and I can look all around this tank. I can look all around and see really the interior of the tank, and also I'm shooting lasers right now. But yeah, this is, look around, shouldn't be able to do that, but yeah, that is how to set up something in virtual reality in Unreal. And as you saw, both of these are really easy to set up because, well, it wasn't so easy back then in Unity when I was first starting off with virtual reality, because you had to do a lot of extra steps, and you have this button you can just click. You can automatically go in VR, but it's so much easier now, and it's really meant for a lot of people to explore and really just make some project ideas, go along with it, see what you can improve later on. So, and by the way, this game, no code. It was made entirely in the Blueprint scripting system, which Unreal supports, and we are trying to get it to C++ code later on, but if you're not a computer science major, this is really a good place to start off to just visualize your logic. And if you ever need some help, you can come to the VR Club as well. That's what I've been saying. But yeah, so. So what are some best practices that we can get in our VR games? We already talked about some before, but for a game specifically for these types of engines, one thing is locomotion carefully managed. So if you're making a movie, if you're making a moving object, and I'm sitting on this moving object, but when I turn the vehicle, I'm still looking forward. I'm not turning with the vehicle. The player feels really sick. And an example of this can be a motorcycle simulator, where I am just moving moving constantly, looking forward, and all of a sudden I turn. Oh my God, the vehicle's like right here. It's just a disconnect between what you're seeing. You're supposed to be rotating with the vehicle, not just being up here still. So you need it's a good practice to manage that and make sure that doesn't happen. Also,
to add on top of that, most of the time, locomotion, even if it's done properly, like if you have like a roller coaster or just a car driving, where you don't actually have to work with any tilting or rotation of the camera, you have to be very careful about that, because some people get motion sick even when locomotion is handled properly. So most of the time when you're making applications, especially when you're starting off, you want to make something that doesn't involve any locomotion at all. Just have somebody standing there, because it's very unsettling for someone to be still at one point and then have something moving in front of them when they don't actually have the sensation of moving in a vehicle. They're still sitting in a laboratory or whatever development space you have.
and while we're on the topic of unsettling things, this next one, avoiding direct contact with projectiles. So you don't want a watermelon coming straight to your face and blasting you and getting really terrified.
You think you would never fall for this in VR, but it really does feel like that might actually happen to you if a projectile gets flung at you like that.
And this is actually one of the things on the Oculus page of best practices. There's actually a whole list. You should go take a look at that if you're interested in doing anything VR related. There's an entire list, and this is one of them, avoiding direct contact with projectiles. So while it may seem like a good idea to have watermelons come out of your face and scare the player or just get a reaction out of them, it makes them really unsettled. It's just something that should be pretty much avoided unless you're making a horror game. But that's a different story. That's, you want to evoke unsettling stuff. And another thing for best practices is making sure that your frame rate is smooth across the entire game. So if you have that sphere that I made in Unity, and then all of a sudden, oh, I'm just going to spawn 10,000. No, you don't want that to happen, because then you're just going to get a really drop in frame rate. And it's going to go from 75 frames per second to like 10 frames per second. And it's important to keep your frame rates consistent and smooth throughout. And another thing with best practices is the body motion. So with a lot of these touch controllers that are coming out, so we talked about the half moon controllers. If you haven't seen them, basically you just hold them in your hand, and in the virtual environment you're allowed to manipulate certain objects. And this would be, like an example would be playing pool, to be able to hold one of these objects, pull it back, and it will be reflected in the virtual environment. So, but when you're looking down and you see your body, that is something that's really immersive. Seeing a body that you think is yourself, people freak out. They try to like touch themselves and, whoa, is this really happening? So, but this is something that can't really be solved right now, or it is really hard to do, because your head can go inside your body and you can shift your head from your body, and that's just going to look weird. My head's over here and I'm seeing my body. Wow, that looks really weird. But a game that does do this right is called Eve Valkyrie, and Eve Valkyrie is a online, the first of it, like the first that's ever been an online multiplayer spaceship battling spaceships that battle each other in VR. So they have the body down perfectly, because if you move your camera in a certain orientation, the body adjusts to that. So that is pretty hard to do right now, to make sure the body adjusts perfectly. And they don't do it perfectly, but they do it pretty well. But it's just still, a lot of games don't have it.
And actually, in Valkyrie, if you are in your space station selecting through, going through menus, and you're actually standing in a standing position behind the camera, you can actually walk in different locations around the space station, and they don't even try to guess where your body is. They just keep it there, so you actually detach from your body, and you're like a floating head moving around, seeing this body, headless body that's you. So they just decided to just ignore that, because it's too challenging to try to guess where the person's body is because there can be so many different types of orientations. So just generally avoid that.
Yeah. And also, don't hard set the camera because, so in Unity and Unreal, there are cameras that you can put in the scene that render the entire scene. And if you fix it out of position, basically you're limiting the person's movement, so you're just going to be shuddering like this, and that's not the purpose of virtual reality. You're supposed to be able to look in all directions and not be limited to just one view. Do you want to talk about these practices?
Oh yeah, sure. So if you have a head, like a HUD element in your virtual reality application, like you have a little reticle in the front that's pointing at something so you can see where it is that you're facing, you want to do some math calculations on where that point is in space. So let's say if this was a virtual reality classroom, like I was the player. If I'm looking over maybe at that wall over there, the reticle should actually go all the way out there, and then change its size to a much larger size so that it doesn't appear to get any larger or smaller, but the depth, or at least the parallax of your eye angle, because if you're looking at something that's closer, even in VR, the parallax angle is going to be much sharper. So you want to generally adjust the reticle's point to wherever it is overlaying object in 3D space. That way you don't get any sort of this double vision. Something I did very early on is I had a HUD display that didn't do that. And whenever I'd look at something close inside the cockpit, it handled it okay. But if I looked outside the window at a much farther distance, I would actually see two reticles because the parallax angle of my eyes actually became less, and that split the actual object itself. So it's just kind of an unsettling thing to deal with. So make sure that it's always adjusting to whatever it is that's being impacted. You should never change the field of view of the Oculus camera. The standard ones that they set for the Unreal Engine and Unity are just fine the way they are. You don't have to adjust them or make their field of view wider or shorter. They account for that already and have the optimal one. And then always allow free camera movement. This goes back to hard setting the camera. If you hard set the camera at a certain location, you're not actually going to hard set. There's no way to keep the user's head facing one way. So if they move their head over, it feels like they're moving the whole world over wherever they're looking, and it's extremely unsettling. It even makes me sick, and I have a pretty strong stomach. This is just one of the screenshots of the game we showed you earlier. So this is actually a map that was done by an artist at DICE with the Unreal Engine, so it just has some capabilities of the graphics of Unreal Engine. And
this is a Unity game. It's made in Unity. It's called I Expect You to Die. And I don't know how many of you have heard of this, but basically you're a secret agent, and you're supposed to you're on a plane. You're supposed to get this car out of the plane, and you have to look everywhere in order to find out how to escape from this car. So what's really good about this game in VR is its use of interacting with everything around you. You use the entire space to interact with objects, to pick them up, try to find out. At one point, I had to defuse a bomb or something. So this is one of the games made in Unity that allow for a really nice range of motion, just looking everywhere, and it's really cool. And it's actually available to play in the VR lab if you ever want to try it out. And this is another game made in Unity that is not a VR game, but since it is made in Unity, that's why it's up here. And basically these three creatures that you see are, in an actual game, you construct spaceships and you're trying to go to different planets. And basically, people had an idea of asking the creators of this game, oh, can you make this a VR game? Because it'll be really cool to see the different planets and really see the details on these planets, something really close up, and be able to be immersed into this game. So another example is Surgeon Simulator, also made in Unity, and basically the concept of the game is kind of silly because you're trying to save this person and trying to remove organs, like see what's wrong with him and try to revive him. But this is actually a port. There's a port made for this in VR, and they also use touch controllers, so you're able to act like a surgeon and basically not dissect, but get certain organs out. And like in this game, they like throw organs everywhere. It's very sporadic, but the point of this is that you don't have to, if you're trying to make a VR game or experience, you don't have to just focus on making a game. Like obviously a lot of VR stuff right now are games. That is the target audience. They are gamers because of all this stuff with looking around. It's really immersive for the gamer, but some of these, like the Surgeon Simulator, the space game, they are the sort of things that can be actually practical. Obviously not like throwing organs everywhere, but you can actually, like a lot of surgeons have been actually developing stuff using VR and seeing if that's comparable to standard surgical procedures and practices. And to optimize some of these game engines we talked about, one of the things which I showed you earlier was the poly count on the object. So on that sphere that I had in Unity, it had almost 1 million vertices, right? And basically you want to limit the amount of vertices on a certain object. You can always optimize models to look better. There's a lot of practices going on to try limiting the vertice count in order to make the object still appear what it looked like, but make it better for the performance for VR applications. And also in this picture we have 3 Earths. One of these Earths is lower poly than the other Earths, and this Earth at the top left is the most optimized. And a way you can, a concept that people have been using for VR games is called level of detail variant. And if I'm farther out, if the distance between me and the Earth is really far, then I'm going to use the very low poly Earth model because it has, I don't need to render that much information on the virtual reality headset to me at that time because it's very far away. Why do I need that much detail about it? But as I zoom in closer, I get a better model, and that's what these bottom 2 models are. They are more optimized. And yeah, so one of the final things I want to talk about is procedural generation. And how many of you have heard of Minecraft? I'm sure a lot of you. Yeah, so one of this, someone who is really good with Unity made basically Minecraft procedural landmass generation simulator. And this is not in VR, but it shows you the potential of procedural generation in VR and how it could optimize performance. And there are a lot of other procedural things, such as procedural animations, music, that can be incorporated from, so you can use a lot of stuff from a game, because a lot of this is used in the game. Procedural stuff has been known. But putting that in VR would really allow people to see changes of landscape, changes of music, just really give them that immersive experience as they can. And this Minecraft landmass generator is interesting because it shows what can occur in VR, and it looks pretty nice too. I mean, this is made in Unity, and if you can get something that looks really nice in VR and have a good frame rate, then your game or experience is would be really interesting to anyone who tries it out. And another thing is particle systems that come in Unity and Unreal. And basically, this is related to what we talked about with that sphere with a lot of vertices. You don't want to have so many objects spawning in the game because that limits the performance of the frame rates and also the environment size. Like something like this would probably not work in VR unless you are able to really shrink the size and just get something that performs better for the headset. So.
All right. One more thing on procedural content is that it's a really effective way of rendering something in the environment because processing speeds have been getting constantly faster and faster, whereas pulling something from memory, like a pre-made image, is the amount of time that it takes to process that is also getting faster and faster, but not at a rate nearly as fast as processing time. So procedural content is going to be getting more and more popular because it's going to be more optimized for modern machines. So if you make a texture like grass or something that you want to spread over a long period, over a large base, you can do it procedurally and generate a level of detail that if you go closer and closer to it, it generates more and more detail of the grass. And that allows you to really optimize your game and tailor it to more modern machines in their hierarchy. So that's it for us. We're the president and vice president of the Virtual Reality Club. We have classes every Wednesday here at 5 p.m. Usually they're here at 5 p.m. And some of them will go into more specific things, like we have modeling classes specifically for making models optimized for VR. We'll have technical classes where you're going to be coding with Unity or working with the Unreal Engine nodes-based editor, and even working with sound. So we're actually going to be doing we're going to be doing a virtual reality sound class next month, which we'll announce if you are on our email list or on the Facebook group. If you're not on either one of those, you can get on our email list by sending a message to umdvrclub@gmail.com. You can join us on our Facebook group. And then we also have game nights on Friday at 6 p.m. They go from 6 to 8, where you can just come into the lab in AV Williams 1120, and you can play virtual reality video games like ours as well. So we actually have tournaments for VR games. You don't have your own headset. You can come try the games there.
Okay, so right now we could take any more questions if anyone has some about VR in general, or the classes, or the VR club. Pretty much, yes.
When did you guys get started in VR?
So I think it was only a year ago where we went to a hackathon at Virginia Tech, and we worked on a motorcycle simulator that was pretty bad because of the locomotion thing, where the vehicle was tipping over and the head wasn't responding correctly. But that's where we got a lot of stuff. We did this in Unity, and we really liked the idea of trying to make something in VR and seeing how we can optimize it. Obviously, at that time we were new, so we weren't really familiar with Unity or VR. But over the summer, we worked on a tank game in Unity, and then we decided to transfer over that later to Unreal because of the better graphics that we encountered with Unreal. Yeah, so we only started about a year ago, and a lot of this VR equipment wasn't really known at the time. Like, I didn't even know it at all, or he didn't even know it when we entered, when we came into the University of Maryland the first time. but we heard that Brandon Reed had a big donation to the University of Maryland and brought some DK2s, and we were able to bring some to the hackathon. That's when we got started.
One of the biggest reasons why we started the VR Club was that Mike and I really wanted to work on VR applications, but nobody on campus knew how to do anything with virtual reality. So we actually had to spend the whole summer going online and just doing online tutorials. And Mike and I both thought, well, it'd be a really great idea for us to start a club so that the knowledge that we've gained, we can share with everyone else and have you guys, put you guys through a much more accelerated learning program to develop VR applications. That's why we have lab hours where you can come in, and that's why we have classes every week.
Yeah.
Any other questions?
So
Someone always be collaborating.
Whenever there's initials on the, So we have a document on Google, on Excel, like a Google Sheets, where you can access it on our Facebook group. Are you on that? Okay. Are you on the emails? Okay. Well, if you come to A.V. Williams 1120, there's a poster that has them posted. They're not the true hours anymore, but if you come later in those periods, like 5 p.m. or later, that's when most of us are available. You can come 5 to 8 p.m. Mondays, Thursdays, and then Fridays from 12 to 8 p.m. is when we're in there as well. So.
But yeah, we have a sheet of all where our initials are next to the time. That's what we'll probably put it on this Hacktorial event page. And also put the UMD VR Facebook group, a link to that. So you guys, if you're interested in joining that, you can. Okay. Any more questions? Right? Oh, yeah.
I was kind of like timeline for creating a game. I looked up the full game. Let's say it has the background or one room inside the game. Like, how long would that take?
So of course it depends on the skill level of the developers, but it took Mike and I, who had zero experience, Mike and I, 36 hours at a hackathon from knowing nothing even about Unity. We didn't even have any experience with Unity to making a VR application. It was crappy, but it worked. It was a motorcycle sim that you could drive through, like on a whole racetrack, in 36 hours. So, and it was just Mike and I who were doing it. So we're not like geniuses, I'd like to think I'm pretty smart, but it depends on the developers. But you can get something, especially now with the game engines already incorporating VR into their cameras, so you could just enable it through the steps we just showed you. You can get something up and going in like an hour or two. So.
Yeah,
it's really quick.
If you ever needed help, you can always come to the lab hours, and if you want to set something up, we'll be there and assist you.
Yeah, and I taught middle school students how to develop a space dogfighting simulation in virtual reality over one summer. So if I can do that, I'm sure University of Maryland students could handle development for VR pretty easily.
All right, well, thanks everyone for coming, and thank you. It was really fun to do.
All right, thanks, guys.